Welcome back, Algebra 1 students, to another Regents review video. This is the Algebra 1 Common Core Regents exam. This is the August 2016 administration, and these are going to be the solutions for parts 2 through 4. These are the open-ended free response questions that requires you to show your work, which, by the way, showing work, if you decide to take my work and hand it in for homework, that is the wrong thing to do. Do not, under any circumstances, cheat. It's not going to help you. But if you're here for assistance because you really don't know how to do a problem, or you're here to check your solutions, by all means, welcome. Hit that subscribe button down below and make sure that you visit my website at www.nysmathregentsprep.com. And just a quick reminder that I use the TI Inspire CX. It is quite an amazing tool. You can find the link on my website to Amazon. I don't make any money. I promise I don't make any money off of those calculators. All right, without further ado, let's begin. All right, 25. 25 says graph the function y equals negative the square root of x plus 3 on the set of axes below. So the first thing that I want to think about is go to your graphing calculator and just graph the function negative square root of x plus 3. And we get this, okay? So what we're going to do here is we're just going to do Control-T, and we're going to go all the way down to where it says error. Okay, so the first point that we're going to plot is negative 3, 0. So you can make an XY chart or listing. All right, so here's my XYs. And I'm going to plot the points, and I'm only going to plot whole numbers. So negative 3 is good for your X values, negative 2 is good, 1 is good, 6 is good, and that's it. So we're only going to plot those few points. So we're plotting the point negative 3, 0, negative 2, negative 1, 1, negative 2, and 6, negative 3. Those are the coordinates that I chose. Now from here, you're just going to plot those points. Plot that point, negative 2, negative 1, 1, negative 2, and 6, 2, 3, 4, 5, 6, down 3. And that, ladies and gentlemen, is how you graph that function, and that is going to be y is equal to negative square root of x plus 3. Just draw and label. Make sure that your arrow is pointing at the very end of this on the right. If you drew an arrow over here, you're going to lose a point on the regions. Do not do that. All right, and that's how you do question number 25. Moving on to 26. Richard is asked to transform the graph of b of x below. The graph of b of x is transformed using the equation h of x equals b times x minus 2 minus 3. Describe how the graph of b of x changed to form the graph of h of x. So what's going on here is we are analyzing the transformation that occurred. If you have a number that is inside of a parenthesis, that is suggesting a horizontal shift. Now, a horizontal shift is opposite the sign, meaning that if it's negative, you would think it's going to the left, but it's actually the opposite direction of what the sign is. So the direction is opposite the sign. So that means that this is going to be horizontal shift to the right by 2 units. This number over here, this is a vertical shift. Okay? And it is the same sign, meaning that the direction that you go is same as the sign. So we are going to say that h of x is formed by translating, which just means moving, translating b of x to the right by 2 units, followed by translating down by 3 units. And that, ladies and gentlemen, is a proper description on how to explain how it was transformed, because it did say describe, so you actually do need to be specific in order to get that question right. All right, and that is how you explain it. All right, moving on to question 27. 27 says, consider the pattern of squares below. Which type of model, linear or exponential, should be used to determine how many squares are in the nth pattern, meaning the next set of blocks, and explain your answer. So this is showing 2. This is now showing showing 4, and this looks like it's showing 8. 1, 2, 3, 4. Yep, 8. So it looks like that we're multiplying by the number 2. Looks like we're doubling each time. That's not linear, that's exponential. So we are going to say that our answer is exponential model because the pattern, because this is showing a pattern, the pattern does not increase at a constant rate. That is a definition of a linear function, folks. It doesn't increase at a constant rate, so therefore it can't be a line. If it doesn't increase at a constant rate, it cannot be a line. Instead, it doubles each time to generate the next term. And that is how you answer that question, folks. Not too bad. Not too bad. Just know that it's exponential because it is not increasing at a constant rate. All right, moving on to 28. When multiplying polynomials for a math assignment, Pat found the product to be negative 4x plus 8x squared minus 2x to the third plus 5. He then had to state the leading coefficient of this polynomial. Pat wrote down negative 4. Do you agree with Pat's answer? Explain your reasoning. Okay. I hope that your algebra teacher drilled this into your head, and if he or she did not drill this into your head, I will. You have to list your terms in descending power order every single time. So when I say descending power, you're looking at the powers of 1, 2, 3, and this technically has a power of x to the 0. So descending meaning start off with the biggest and decrease each time. This is what his answer should be in the first place. This is the correct way of writing it. So the leading coefficient is attached to the highest degree. So the highest degree in this case is 3. This negative 2 is actually your leading coefficient, not negative 4. So we're going to say that Pat is incorrect. So we're going to say, well, it says, do you agree with Pat's answer? No. So no, Pat is wrong. The leading coefficient of a polynomial is attached to the highest ordered variable. In this case, negative 2x to the third has the order of 3. Order just means power. You could just write power of 3 if you really want to. And therefore, negative 2 is the leading coefficient. And that's it. That's how you explain your answer. All right. That's number 28. Moving on to 29. These part 2s so far, not too bad. Not too bad. 29. Is a sum of 3 radical 2 and 4 radical 2 rational or irrational, and explain your answer. So, radical 2, you should know by now, or just by typing it into your calculator, but radical 2 is kind of a common number. Radical 2 is irrational. Okay? So, and it's the sum. So when you add 2 irrational numbers, your result is going to be irrational. So your answer is irrational. The sum is irrational. Since the square root of 2 is an irrational number. The addition of 2 irrational numbers will result in an irrational number. That's it. If you know that the sum of 2 irrational numbers will result in an irrational number, you're perfectly fine. You got this question right. All right, that's how you do question number 29. Question 30, moving on. The graph below shows two functions, f of x and g of x. States all values of x for which f of x equals g of x. So you're basically figuring out where these two graphs cross each other. So they're clearly crossing here and here. The x value, if you just go down, this is, let's see, -1, -2, -3. So this is x equals -3. And this over here, this is x is equal to +1. So your answer is going to be x is equal to the swirly bracket of -3 and 1, close a bracket. And that is your answer. Now, you don't need to necessarily write it in that notation. You could just say x equals -3 and x equals 1. That's perfectly fine as well. All right. That one was just a question just to really take the 2 points and run with it. Not too bad. 31. Find the zeros of f of x equals x minus 3 squared minus 49 algebraically. So, what you need to do is you need to simplify this as much as possible in order to factor it. Remember, we're trying to factor this because it says specifically find the zeros. So we need to set this equation equal to 0. So we have x minus 3 squared minus 49 equals 0. Okay. There's two ways you could do this. Either you could FOIL this, and then you factor, and then you do the trinomial method of factoring, what adds to the middle term but multiplies to give you the constant term, and then set those factors equal to 0. Or, better yet, if you actually add 49 on both sides, like this, this then becomes x minus 3 squared equals 49. You could then take the square root of both sides. This will then become x minus 3 equals plus or minus radical 7. Sorry, not radical 7. Plus or minus 7, because the square root of 49 is 7. But it's plus minus 7 because we have to take into account that two negatives could result in a positive number. So it's plus minus 7. Now we just add the 3 on both sides, and you get x is equal to 3 plus minus radical 7. I keep saying radical 7. My apologies. It's just 7. Okay, so now there are two answers that result from this equation. We could break this down, and this becomes x is equal to 3 plus 7, and this becomes x is equal to 3 minus 7. So 3 plus 7, that's just going to be x equals 10, and this over here, this is going to be x is equal to -4. So your x values, or your answers, that's x is equal to the swirly brackets of -4 and 10. And that, ladies and gentlemen, is how you solve that problem. Now, could you do the FOIL method? Of course you can, but I find that this way is a little bit easier than factoring it out and distributing and doing all that fun stuff. But do whatever way you want to do it. All right? So, let's move on. Here we go. 32. Solve the equation below for x in terms of a. So solve for x in terms of a. So the first thing that we got to do is we have to distribute that 4. We then get 4ax plus 12 minus 3ax is equal to 25 plus 3a. Okay, so the 4ax and the -3ax can combine to give you ax. Plus 12 is equal to 25 minus 3a. Now, we are going to subtract that 12 on both sides. We then get ax is equal to, that looks like 13 minus 3a. Now it says solve for x, so we're going to divide by a on both sides. So we just get x is equal to 13 minus 3a over a. That, ladies and gentlemen, is your answer to this equation. Now, if you wrote this answer, x is equal to 13 over a plus 3, you would also receive full credit. So either one of those two answers would give you the full amount of points for this question. All right, that is the conclusion of the part 2s. Now moving on to the part 3s. Here we go. It says the data table below shows the median diameter of grains of sand and the slope of the beach for 9 naturally occurring ocean beaches. Write the linear regression equation for this set of data rounding all values to the nearest thousandth. take these points and run with it. You just plug these into your calculator. That's it. Plug it into the calculator. So we're going to go here. I'm going to go to lists and spreadsheets. That is this little greenish button down here. Lists and spreadsheets. And I'm going to type in my X, and this is my Y. All right, here we go. 0.17, 0.19. So what we're going to do is we're going to type in all of these values, and then we're going to analyze it in our calculator by plugging these values into linear regression. Now, if you have a different model calculator, I'm not so sure how you're doing this right now, because I know that other calculators can do this feature, like the TI-84. But in my opinion, this is just so much faster and easier than other calculators. So if you didn't consider buying it, maybe you should reconsider that, because it is one awesome tool. And it will help you in algebra too, I promise you. Geometry really doesn't use the calculator that much. Okay, so we have those values. Great. Now from here, what we're going to do is press Control-Dock, add a calculator. Go down to Menu, go to Statistics, go to Stat Calculations, and then go to Linear Regression MX plus B. Your X list is just your X, your Y list is Y, and then you click OK. Then we come up with these values right here. Now, your job is to actually copy, not the whole thing, but you're trying to copy this onto your test paper. I would suggest that you copy the top line, the title linear regression, and you copy your M value and your B value, and you copy down your R value. I think that those 4 lines of text would be awesome to write down on your Regents exam. So, I am going to write title. We are working with linear regression. Your M is 17.1594. Your B value is negative 2.4759, and your R value is 0.9542. Now it says round all values to the nearest thousandth. So remember, we're trying to plug this into Y equals MX plus B. So we get Y is equal to, the M value is 17 point what? Well, this is tenths, hundredths, thousandths. So we need the number afterwards, the 10,000ths place, to figure out what the thousandths place is. Since 4 is less than 5, this just stays at 159. X plus your B value of negative 2.476. So, ladies and gentlemen, that is your answer. Y is equal to 17.159x minus 2.476. That is the answer to the linear regression equation. Now, there's a follow-up question. And the follow-up question states, using this equation, predict the slope of a beach to the nearest tenth of a degree on a beach with the grains of sand having a median diameter of 65 millimeters. So all you need to do, this function here is a function of the slope of a beach. And it's saying, predict the slope of the beach. Okay, so all we're going to do is we're going to take our equation, which is y is equal to 17.159x minus 2.476, and we are going to plug in 0.65 into our equation. And make sure that we are in proper units. This is millimeters. This equation is in millimeters, because sometimes they ask you to convert things, so just be careful with that. So we get y is equal to 17.159 times 0.65. Okay, that's it, minus 2.476. When you get that into your calculator, that is approximately equal to 8.7, rounded to the nearest tenth of a degree. So y is equal to 8.7. That is the slope of the beach with a median diameter of 0.65 millimeters. Okay, that's it. 34. Sean incorrectly graphed the inequality negative x minus 2y is greater than or equal to 8 as shown below. Explain Sean's mistake. So the first thing that I want to do is I want to actually figure out what this is. Well, this is negative 2y is greater than or equal to, I'm going to move that x over. So we get x plus 8. Divide by that negative 2 on each side. We get y is less than or equal to. Remember, you flip the inequality when you're divided by a negative. So y is less than or equal to negative a half x minus 4. So Sean definitely graphed this correctly in terms of the line itself, but he shaded above. this should be shading below. So it says here, explain Sean's mistake. We're going to say the shading should be below the line since dividing by a negative flips the inequality sign. That, ladies and gentlemen, is perfectly acceptable. Something on the lines of that. Okay, and that's how you answer the first part of this question. Now the second part says actually graph the inequality on the set of axes below correctly. So I'm just going to take y is less than or equal to negative 1/2 x minus 4. All right, so the slope is equal to negative 1/2. Your y-intercept is 0, negative 4, and it's solid shading below. Great, let's go ahead and graph it. So down 1, 2, 3. So we're going down 4, and we're going down 1 to the right 2. Down 1 to the right 2, down 1 to the right 2, and you just keep on going until you stop at the very end. There we go. And then we could go in reverse if we really want to. Like that. Now from here, all you do is you connect those dots. Like that. Boom. Now from here, we are shading below. So this, ladies and gentlemen, is going to be shading below. Make sure that you label it. That's y is less than or equal to negative 1/2 x minus 4. And you are done. All right, moving on. 35. A drama club is selling tickets at the spring musical. The auditorium holds 200 people. Okay, it sounds like already that there's going to be a system of equations here. Tickets cost $12 at the door and $8.50 if purchased in advance. The drama club has a goal of selling at least $1,000 worth of tickets to Saturday's show. Write a system of inequalities that can be used to model this scenario. So the auditorium holds 200 people. Okay, so there are two types of people for this, and this is probably the trickiest part of this question. There are two types of people. The X people, the people for X, those are people who buy at the door. Okay? Your Y people are the people who purchase in advance. Okay? So, the auditorium can hold a maximum of 200 people. So that means that your X people plus your Y people has to be less than or equal to 200 people. That's the capacity of the auditorium. Now, they want to sell at least $1,000 worth of tickets. So that is going to be $12 times X plus $8.50 times Y has to be greater than or equal to $1,000 because who wants to stop at $1,000? So it has to be greater than or equal to 1,000. So that's it. Write a system of inequalities. We're done. Basic, simple question. Okay. Chances are they're going to ask us to solve it. Yeah. If 50 tickets are sold in advance, what is the minimum number of tickets that must be sold at the door so that the club meets its goal? Justify your answer. So, it's saying if 50 tickets are sold in advance, what is the minimum number of tickets that must be sold at the door so that the club meets its goal? So, all we're going to do is we're actually going to use the second inequality. We're going to use the second inequality because, look, people thought 50 tickets are sold in advance. They immediately plugged in for Y. They said X must be 150. No, not how it works. They want to figure out what is the minimum number of tickets to reach their money goal. This is all about money. We're talking about money. So we're going to use a second inequality. So we get 12x plus 8.50y has to be greater than or equal to 1,000. So I'm going to plug in 50 tickets in for y. So we get 12x plus 8.50 times 50 is greater than or equal to 1,000. 8.50 times 50, that's just going to be 425. So 12x plus 425 is greater than or equal to 1,000. We're then going to subtract 425 on both sides. Oops. Okay, we got 12x has to be greater than or equal to 575. And last but not least, we're going to divide by 12. And then we get x must be greater than or equal to 47.9. Now, it's saying what's the minimum number of tickets. In order for them to achieve their goal, they must sell 48 tickets. It can't be 47 because that's not enough. They must sell 48 tickets to meet their goal. And that is your answer, ladies and gents. That's how you solve that problem. All right, last of the part 3s, which I'm going to be completely honest. I remember when this Regents was administered, and I actually had a teacher walk up to me. I'm not going to mention names, but a teacher walked up to me, I think during the Regents exam, and she was like, I can't believe that they did this. Well, let's take a look at this. Janice is asked to solve 0 equals 64x squared plus 16x minus 3. She begins the problem by writing the following steps. All right, so we have line 1, line 2, line 3. Use Janice's procedure to solve the equation for x. Okay, for some god-awful reason, she's all of a sudden substituting in b's. So I'm going to say to the I'm going to draw an arrow from line 2. So I'm going to write down, notice 2b, okay? Notice the expression 2b. 2b and 16x. So 2b and 16x must be equal to each other because they're actually in the same position. So 16x is equal to 2b. Divide by 2 on both sides. You're going to let b equal 8x. That was the key to this question. So b, for some reason, she made b equal 8x. I don't know why she did that. But it says, use Janice's procedure to solve the equation for x. So I'm going to say use line 3, where b is equal to 8x, to solve for this equation. So I'm going to take line 3, which is 0 is equal to b plus 3, b minus 1, and I'm going to plug in 8x for b. So we get 0 equals 8x plus 3, 8x minus 1. We're going to t-bar it. We get x is equal to negative 3/8, and then we get x is equal to positive 1/8. So it says solve the equation for x. I'm just going to make my swirly brackets. X is equal to negative 3/8, comma 1/8. And that, ladies and gentlemen, is the answer to solve this equation for x. It was definitely a strange question in the way that Janice did it. I don't know why she wants to overcomplicate things. But then, of course, they want to overcomplicate the Regents. Explain the method Janice used to solve the quadratic equation. Okay, so we need to explain basically what she did. So we're going to say that Janice substituted the variable b for 8x, which is what we said back here. We said let b equal 8x. So she substituted the variable b for 8x. Okay. She did this to simplify the quadratic. Okay? Once she factored, she replaced the b with 8x. Definitely a weird way to do things in math, but that's what she did. That's what she did. Okay, that's the last of the part 3s. Moving on to the very last question, the part 4. Here we go. For a class picnic, 2 teachers went to the same store to purchase drinks. One teacher purchased 18 juice boxes and 32 bottles of water and spent $19.92. The other teacher purchased 14 juice boxes and 26 bottles of water and spent $15.76. Write a system of equations to represent the costs of a juice box J and a bottle of water W. So, I'm going to write the first equation. Equation number 1. This is for the first teacher who went to the store. So we're going to say that the first teacher has 18J plus 32W equals $19.92. This means that she bought 18 juice boxes plus 32 water bottles, and she spent a total of $19.92. Okay? And then the other teacher. So, equation number 2. So this is going to be 14J plus 26W is equal to $15.76. So this particular teacher, he spent $15.76 on 14 juice boxes and 26 water bottles. Okay. So this, ladies and gentlemen, is your system of equations in order to solve this question. Great. All right, moving on to the next follow-up question. The next question says, Kara said that the juice boxes might have cost 52 cents each, and the bottles of water might have cost 33 cents. Use your system of equations to justify that Kara's prices are not possible. So, here we go. We're going to take 52 cents and we're going to plug it into, I'm just going to plug it into the first equation here. 18J plus 32W equals 1992. So 52 cents is the same thing as saying 0.52. Just be careful. So I'm going to take 18J plus 32W equals $19.92. So I'm going to plug in 52 cents for J. So we get 18 times 0.52 plus 32W is equal to 1992. Okay. 18 times 0.52, that is equal to $9.36 plus, I'm sorry, my apologies. I forgot to plug in 33 cents. My sincere apologies. Hold on one second. This is 0.33. Okay, so the water should be 0.33. 0.33. There we go. So $9.36 plus 32 times 0.33, that's $10.56, and that's going to equal $19.92. So when you add these, well, let's figure this out. Let me open up a new page here. So $9.36 plus $10.56. Oops, I forgot the 5 cents. All right, 5. Oh, wait a minute. $19.92? What are they talking about? They're equal. So why are they saying that it's not possible? So Kara's correct in terms of this equation. But there is a second equation that we need to test. So yeah, you actually had to test both equations to see if they work. Let's test the second equation. So I'm going to use 14J plus 26W is equal to $15.76. So 14 times 52 cents plus 26 times 0.33, that is equal to $15.76. So when you multiply these together, we get $7.28 plus $8.58. That's equal to $15.76. Now, from here, when we add these up, this will give us $15.86, and that is not equal to $15.76. So, Kara is incorrect. So, we are going to say in our answer that Kara's prices are not possible because it did not satisfy equation number 2. All right, that's it. That's how you explain how Kara is incorrect. So just be careful that you have to use the second equation to prove that Kara's prices are not possible. All right, moving on to the last part of this question. And it says, here we go. Solve your system of equations to determine the actual cost in dollars of each juice box and each water bottle. So I'm just going to take my original equations and I'm going to put them back over here. So we get 18J plus 32W equals 1992. And we get 14J plus 26W, that is equal to 1576. So without further ado, here we go. All right. So in order to cancel out one of these, I'm actually going to solve for W first. Solve for W. That means that we have to cancel out these J's. So in order to cancel out the J's, I'm going to multiply this by a -7 and a +9. Because the -7 times 18, that will make a -126. And then 9 times 14, that will give you +126. So we get -126J. And that -7 distributes to everything. So we get -224W is equal to -139.44. Down here, we distribute that 9. We get 126J plus 234W. That is equal to 141.84. So those -126 and 126J's cancel. We add these up now. negative 224 plus 234, that's equal to 10W, is equal to 240. Divide by 10 on both sides. You get a water bottle is 24 cents, or 0.24. Now, let's find the juice box. So all we have to do now is once we... This was the hard part. Once you found the price of a water bottle, we could pick any one of these equations and just plug it in to solve for your juice box. So I picked the bottom equation to work with. So the bottom equation, once again, is 14J plus 26W equals 1576. So 14J plus 26 times 0.24, that's your cents for water, equals 1576. So 26 times 0.24, that is going to be $6.24. So 14J plus 624, that's equal to 1576. Subtract the 6.24 on both sides. We get 14J is equal to 952. Divide by 14 on both sides, and then we get J is equal to 0.68. So your final answer, ladies and gentlemen, your final answer is a juice box costs 0.68, that stands for 68 cents, and then a water bottle is 0.24, that stands for 24 cents. And that is how you solve that question. All right, that's the conclusion of this video. I hope that it helped. Make sure that you hit that subscribe button down below and visit my website at www.nysmathregentsprep.com for much more math content in Algebra 1, as well as further subjects in high school math. And I hope to see you soon.